using the incenter of a triangle to find segment lengths and angle measures. All right, so first we need to know what an incenter of a triangle is. So they give us this problem here. The angle bisectors of JKL are JQ, um, KQ, and LQ. They meet at a single point Q. In other words, Q is the incenter of triangle JKL. So they're telling you that these lines, so JQ, KQ, and LQ, and here I'll grab my pencil tool here. Oh, gotta allow it. You know what? I can just scoot it over here. What happened? That's interesting. All right, I just need to swap this really quick so that I can write on this side of the board. All right, so KQ, JQ. Ooh, that one looked ugly. Didn't do that one very good. Okay. JQ going up like this. Oh, I didn't do it very good again. And LQ. Okay, there we go. Close enough. All right, so these three lines are angle bisectors. What that literally means is that they're cutting the angles. So if I go KQ here, it's cutting this whole angle. I can choose a different color here. So it's cutting this whole angle in half. That's what bisector means. So this red line cuts it in half. So this piece is the same as this piece over here. And I know this line didn't come out great, but that's what bisector means, is it means it cuts it in half. Okay. So each one of these lines coming from the vertices to the center, or what they're calling this incenter, are angle bisectors. And where they meet at point Q here is called the incenter. And then you notice there's all these other little lines coming off of the incenter that go down to a perpendicular point on the side. And then they give us a bunch of other information. Before we deal with all this other information, what I want to do is scroll down here and just swap this back really quick. All right. Because I want to write notes on this side. Sorry, my pen only works on half of this because that's the way I've mapped it out for my pen. An angle bisector divides an angle into two congruent pieces. So we've already talked about that. The incenter theorem. So the angle bisectors of a triangle intersect at a point equidistant from the sides of the triangle. The point is called the incenter. So they intersect at a point that is equidistant from the sides of the triangle. So all of these pieces, PQ, NQ, and MQ, are equidistant, meaning that they're the same distance. That's what equidistant means. So if we know that those are equidistant, that's going to help us work out the rest of the problems here. So really quick, I'm going to come over here and I'm going to attempt to draw this triangle here. So we've J, L. I'm gonna do a point here. Kind of makes it a little easier to draw from the point. So these are all my angle bisectors, and then straight down, I have all of these pieces here like this. M, N, P, and here's Q in the middle. And what we need to do is fill in the rest of the pieces. So MQ, they tell us, is 16. JQ, which is this piece here, they tell us is 21. MJP, which is this whole angle down here, the whole thing is 92 degrees. So I'm going to go ahead and put that just off to the side here. And then PLQ, so just this piece is, and don't, I'm not saying that these are the same because they're one arc to one arc, so I'm actually going to use two arcs, just so you know they're not the same. They're saying this one's 18. And then they want us to find, I'm going to use orange. They want us to find PLN, so they want us to find this whole arc angle here. And NKQ, so they want us to find this piece here. And the last one is NQ, so they want us to find this length. All right. So if I know, I'm going to write these over here, PLN, NKQ, and NQ. All right, so I want these three pieces here. And these three pieces, we can find with the information we were given on angle bisectors and the incenter. So I just realized I put an angle mark on that one. That which this is not an angle. This was just side NQ. Sorry. All right, so this one is actually by far the easiest one to just grab really quick because they already told me that MQ is 16. Well, I know from the definition of incenter that MQ, PQ, and NQ are all the same. They're all equidistant from this incenter here. So if MQ is 16, NQ is also 16. So that one was pretty easy to fill in there. Let's look at this angle down here. So this PLN. So this large angle here. Well, remember, this is an angle bisector, which means it cuts it in half. So if we know that this is 18, this side is also 18. Remember, I want to know the whole thing, so I need to go 18 plus 18, and I get 36. So PLN equals 36 degrees. And then I want NKQ, which is this one up here. So this one up here is going to require me to do a little bit of was trying to find my words there. A little bit of remembering, I guess, on triangles. So there's a lot going on in this triangle, but what I wanted to focus on was just the angles, the full angles. So I know this one's 36. We just found that. They told us this one's 92. We need to find the whole angle up here first, and then we'll deal with the half piece. Because all three angles of the triangle have to add up to 180 degrees. I know that. All triangles add up to 180 degrees. So if I take the two pieces that I have, which is 92 and 36, and I subtract it, then I'll know what's left over. And most of the students prefer to combine the two and subtract once, so you end up with 8 and 120. So minus 128. So then we're going to go like this and subtract, and we have 52. So we know that this whole thing up here is 52 degrees. Remember, this is an angle bisector. It cuts it in half. All I have to do is go divide by 2, and I'll have my answer. So it goes in twice and 26. So 26 degrees. And if we scroll down here, we find 36, 26, and 16. So, let me click here. Okay, so I changed it so my pen will work on the whole screen. I'm just going to use this screen as my scratch paper here because that'll be a little bit easier than kind of going back and forth. And I don't really have a lot of notes on this one. We just have to remember this is the incenter. And they tell us again here. So the angle bisectors of, whoops, didn't mean to mark on that, ABC, triangle ABC, are AV, BV, and CV. So remember, these are all angle bisectors. That means they cut all of these angles in half. And they made it a single point V. In other words, V is the incenter of triangle ABC, and they tell you that. Suppose that TV is 6, BV is 11, and you know what? I wonder, I'm going to do a little bit of, I'm going to try to zoom in here to make this a little bit easier to look at. So, oh, I can't see my, bring it over here, and then I can zoom in. All right. And I want to bring, so that's fine. Okay, so this will make it a little easier to write just because that way I can actually write 6 right here. It's not super huge. 11 for BV, and then TCU. So this whole angle, the whole thing, is 36. So not half of it, the whole thing. And then SBV, so just this half, is 56 degrees. So that's a very large angle. Just SVB is 56 degrees. That's going to be a pretty large angle when we put it together. All right, so now we need to go through and start figuring some pieces out. I'm going to change my color here to red. So blue is my given. Red is what we're going to work out. So first, let's look at UV. So we want UV right here. And remember, they gave us VT or TV. Sorry, they gave us TV. Same thing. Saying it that way. And remember, from the in-center definition, all of these lengths are the same distance from the in-center. So if I know TV, then I know UV and I know SV. So this length has to be 6 because TV is 6. All right. So I know that this is 6, and I'm just going to write it in there. Now let's see. I'll change my color to green here. I'll do a little darker green so it's not super bright on your eyes there. And we're going to go to SBT. So SBT. So we want the whole angle here. So I want the whole thing, both halves. So and I just kind of gave it away what we're going to have to do. 56 is a half of the whole thing because remember this is an angle bisector. Bisector means to cut in half. So all I have to do is take these and add them together. So I end up with 12 and 11. So I know that this has to be 112. All right, last piece here. I'm going to do this one in pink. Okay, and we need SAV. So we want this piece here. We want the half, SAV. But remember, just like we did on the example there, I need the whole thing because the only way to find this half is if we know what the whole angle is. I can find the whole angle because I know this whole angle that I marked in green here is 112. This whole angle down here is 36. All of them together have to add up to 180. So if I subtract 56 and 36, sorry, not 56. Let's see. There we go. It's a little better. All right. Sorry, it was 112. That's my mistake there. Oh, and I didn't make the pencil smaller again. Oop. All right. So I want to subtract the two angles that I have to see what I have left. And again, most students prefer, I don't know why I started writing that. Most students prefer to just subtract once. So we have, let's see, 8, 4, 1. So we just want to subtract. I'm going to borrow, get 2, get 3. So we get 32 degrees for the whole thing. Remember, we only want the half. So I'm going to divide by 2. I'm going to get 16. So I'm going to click here and I'm going to click 16. And then I do need to zoom back out so I can click check. And we're good. All right, I'm going to clear. And we're going to go next. Okay, so let's zoom back in on this so that I can write in it a little nicer. All right, so this tells us, again, we have these 3 segments that are the angle bisectors of triangle XYZ, and they meet at a single point G. So we know this is our incenter. So this point here is our incenter. And that means that all of these are the same distance from the incenter. That's what incenter means. So let's go ahead and start putting our information in. And let's see, I'll put it in blue here. So we have EG is 22. And remember, I marked these in pink so that you would start to remember, if I know one of them, I know all of them. So I can just fill that in real quick. And then ZG, so this one down here, is 27. EZF. So this whole angle here is 52 degrees. And then they also give us DXE. So just this half here. They told us it was 46 degrees. Remember, if I know this half is 46, I know this half is also 46. I can just go ahead and fill that in. There's no reason not to fill it in because we're probably going to end up using it. All right, so let's go ahead and switch colors here. We'll go green. So let's go ahead and do the first piece here. So DG, we already filled this in because those are the pink lines, right? DG, that was 22 degrees. All right, DXF. So we want DXF. So we already started filling it in. Remember, they gave us this 46, so I just went ahead and filled in the next part. Well, if I know this half is 46, this half is 46. So all I have to do is 46 plus 46, and I get 92. So I can fill it in with 92 degrees. All right, and let's see, we'll go with red. I haven't done red yet. So we want this last piece here. We want DYG. Oh, just this half, sorry, not the whole thing. I started doing the whole thing. So DYG, we want only half. But remember, we have to know the whole thing so that we can divide it in half. Now, if they gave us the whole thing, great. All we'd have to do is divide by 2, but we have to find it. So we know this whole angle down here, that's the one we just added together, that's 92. They all have to add up to 180. So we're going to subtract the 92 we just found, and they gave us 52. So we're going to subtract that because we're using this already. So again, most students tend to like to rewrite it. So they're just subtracting 1, so 4, and 14. So when I'm subtracting once, I'm adding these two together and then subtracting it from 180. I'm going to subtract, and I get 36 degrees for the whole thing. In order to find the answer, all I have to do is divide by 2, and I get 18. 18, and then I get to zoom out here and click check, and we're good. All right, one more. Okay, so we're given 3 segments that are the angle bisectors of this triangle. They all meet at point Z, which is the incenter. So this right here, whoops, have to click my pen tool. This right here is the incenter. Okay. So this is the incenter, and that means all of these are the same. And I'm marking it with that color so that you remember when we know one of them, we know all of them. So the first thing they give us is one of these numbers. So I know if this one's 14, well, this one's 14, and this one's 14. I'm just filling it in with extra information. 17 is this one here, QZ, because that's what they gave me. And then WQX, so this whole angle here is 92 degrees. And then YRZ, so this part, they said is 16. If I know half, this half is 16, the other half here is also 16. Remember, this cuts the angle in half. So if I know one, I know the other. All right, so let's go ahead and start filling in some of the information that we already have. So YZ, sorry, we already filled in YZ. Remember, they gave us WZ. So it's super easy. We already know they all have to be 14. Okay, the next part is YRX, and that was one that we did start filling in there. So we have, whoops, gotta click my pencil tool. So we have 16 and, don't know why I put a line there. Kind of being silly here. 16. We just want to add those two together. That way it'll give me this whole angle here. So I have 32. I know this one's 32. And the last piece they want is YPZ. So let's go ahead and do this one. I haven't done like a real pretty blue-green. Let's do that one. So they want YPZ, they want this piece right here. Right there like that. Remember, that means we need the whole angle so that we can then divide by 2. So I know the whole angle up here is 92. They gave us that. We just found this whole angle here, which was marked with a blue arc, is 32. So I have 180 minus 92 and 32. If I add these two together, I get 2 plus 2 is 4. 9 plus 3 is 12. So I'm using 124 degrees of the 180. So I'm subtracting, and I get 56 degrees for the whole thing. I only want half of it. 2 goes into 5 twice with 1 left over, goes into 16 8 times. Started to divide by 4 in my head for some reason. So we should have 28 there. All right. So I'm going to go, whoops. Don't know what happened with the keyboard there. I was typing some crazy stuff. All right, check. And we finished that one. Yay.